Okay, this is a lecture on the nature of waves. A wave is any disturbance that transfers energy through matter or space. And so up here at the top I can see a surfer in a wave. That water was pushed by wind, and that's what made the wave in the first place. The wave can crash onto rocks, and the energy carried by the ocean waves can break rocks. Waves are created when a source, like these drops, causes a vibration. So the source would be the water dropping in, and then the vibration would be the waves. Here, the source is the sun. All the different kinds of lights strike this object, but only red is reflected back into the eye. Here, this woman is moving this slinky back and forth, and here the hammer hits the table and the sound is carried to the ear. Waves are moving energy. The direction of the particle movement is back and forth here, and the direction of energy transfer is along the wave, from one side to the other. The energy causes materials to vibrate. Waves carry the energy only, not matter, and you can see that with this duck. Even though the wave is going past the duck in these pictures, the duck is staying in the same place. The matter through which a wave travels is called a medium. So a medium is either a solid, liquid, or a gas, and the salt water is the medium for the waves. Waves are classified. Transverse waves are waves in which the particles go up and down, and longitudinal waves are waves in which the particles go back and forth. So transverse waves, waves in which the particles vibrate up and down. The crest is the highest point on the wave, and the trough is the lowest. The rest position is going to be in the middle. Transverse wave is measured from two identical points on the wave. We often use the crests to measure the wavelength, but you could also use the trough. We could measure the wavelength here, or you could measure that wavelength from two identical points. So here's one, it goes all the way down and comes all the way back up and to there. So two identical points on the wave. That's the wavelength. The amplitude is how high the wave is. Wavelength is measured from two equal points on the wave. Crest is the highest point, trough is the lowest point, and then rest position is in the middle. Longitudinal waves are waves in which the particles vibrate back and forth. There's compressions and rarefactions. The tighter the compression and the farther apart the rarefaction, the more energy in the wave. This one is a longitudinal wave, and this one is a transverse wave. Waves can also be classified by if they need a medium or don't need a medium to travel. So a medium is any kind of matter, solid, liquid, or gas. Mechanical waves need a medium to travel through. Sound needs air to travel through, or water, or sound can travel through steel, ropes, earthquakes, and tsunamis. These are all mechanical waves. Mechanical waves can be either transverse or longitudinal waves. Electromagnetic waves do not need a medium. So mechanical waves need a medium. Electromagnetic waves do not need a medium. This is just any kind of light. We have visible light that we can see, but there are also shorter wavelengths and longer wavelengths. Any of these can travel through the emptiness of space. They're called electromagnetic waves because they have a magnetic field and an electric field 90 degrees to each other. They have elements of both. These are the light that we can see, but there are also shorter wavelengths with a lot more energy and longer wavelengths with a lot less energy. What properties do waves have? They have amplitude, wavelength, frequency, and wave speed. Amplitude is how high the wave is or how tight and spaced apart the compression and rarefactions are. Larger amplitude has more energy. That makes sense. Wavelength is two identical points on a wave or measured from compression to compression. Human eyes can detect electromagnetic waves with the wavelength between 400 and 700 nanometers. So 700 would be stretched out red light, and 400 would be really tightly compact blue light. Bluer and bluer you get to ultraviolet, X-rays, and gamma waves. We use Roy G. Biv to remember the colors, so red, orange, yellow, Roy, green, G, and then blue, indigo, violet for Biv. Roy G. Biv helps us remember the colors. Shorter wavelengths have more energy. That makes sense because you have more wavelengths passing the same point in a given amount of time. Frequency is the number of waves that pass a point each second. Higher frequency is more energy because more waves are passing the same point in a given amount of time. Wave speed is the speed at which waves travel through a medium. It's given by the velocity of the wave is equal to the distance divided by the time. That's all.